Hello everyone. So today we are going to start first chapter of physical chemistry, that is chemical kinetics. Chemical kinetics. Chemical kinetics is the branch of chemistry which deals with number 1, rate of chemical reactions, number 2, factors affecting rate of chemical reactions, number 3, mechanism by which reaction proceeds. Now, for any particular reaction, 3 aspects are always important. Number 1, feasibility of a reaction. Number 2, extent to which a reaction proceeds. Number 3, speed of a reaction. Now, out of these 3 aspects, thermodynamics tell us about feasibility of any particular reaction, whereas chemical kinetics tell us about rate of a particular reaction. Now, talking about rate of a chemical reaction. Now, what do we understand by rate of a chemical reaction? It is the change in any one of the reactants or product per unit time. Or we can also say it is a measure of the speed with which the reactants are converted into products. So, rate of a chemical reaction can be expressed either in the terms of the concentration of reactant, that is, decrease in the concentration of reactants, or increase in the concentration of product. Now here we have used a negative sign. Now the significance of negative sign is, as we know that the rate of the reactant is decreasing with time, so delta R will be negative. Thus, to make the rate of the reaction, the expression positive, a negative sign is put before the expression. Now talking about units of rate of the reaction. Unit is concentration per unit time. Concentration is moles per liter and time second. So it is moles per liter per second. Now let us take one example. Suppose we take example of PCl5, the decomposition of PCl5 into PCl3 plus Cl2. Now if we want to write down rate expression, so it can be expressed either in the terms of concentration of reactant or in the terms of concentration of products. So it can be written as minus concentration in terms of the reactant or in terms of the concentration of product. Moreover, whenever there is any stoichiometric coefficient, we always use that coefficient. Suppose we take another example. This is example, right? If you want to write down its rate expression, then it is written as minus half of N2O5 per unit time 1 by 4 delta NO2 per unit time, or oxygen per unit time. The above rate are known as average rate of a reaction. Rate of a reaction can also be expressed as instantaneous rate of the reaction. The difference is average rate of the reaction is expressed for larger change where we use symbol delta, whereas instantaneous rate can be expressed by using small d. Suppose we take an example, H2 plus I2 gives 2HI. If we want to write down rate of the reaction, that is average rate of the reaction, it is written as delta minus delta H2 upon delta T, or minus delta I2 upon delta T, or half delta HI, half delta HI upon delta T. And if we want to write down instantaneous rate of the reaction, then instead of writing delta, we have to write down D. Minus D H2 upon dt minus D I2 upon dt half D HI upon dt.